Welcome to Study Loop.
Hi guys. So today I'm going to do problem 10 from chapter 1 of University Physics with Modern Physics. And the problem asks us to make a number of conversions from some units to some other units. And so the first one it asks us to do is to convert 60 miles per hour to feet per second. So I'm going to write 60 miles per hour like that. And the way to go about these problems is to always kind of keep track of which units you have in your numerator and which units you have in your denominator. And by multiplying by a series of fractions that are really conversions between one unit and another, you can put the expression into the units that you want. Okay, so what I mean by that is we want this to be in feet per second. Okay, so because miles is our unit of distance here, and we want it to be in feet as the unit of distance, right? We need to find a conversion that leaves us with feet in the numerator and cancels out miles. And this is actually given to us by the problem. It gives us 5,280 feet per mile. And so when we multiply these two together, units will cancel out just like a number would cancel out between two fractions in this way. And so we're left with number of feet per hour. So we multiply 60 and 5,280. So we're in feet per hour. So we're almost there because we want feet per second. So then we need to do one more conversion. Oh, excuse me. That's not what I want. I want to do one more conversion that will leave me with seconds in the denominator. So here I want hours to be in the numerator to cancel out the hours in the denominator in the original expression. So I need to figure out how many hours in a second, or conversely, how many seconds in an hour. So there are 3,600 seconds in an hour. So I'll put 3,600 seconds. Right, so now when we multiply by 1 over 3,600, or equivalently divide by 3,600, we are canceling out this hour in the numerator with this hour in the denominator. Okay, so then we're left with units of seconds in the denominator and feet in the numerator, right? So we should be left with units of feet per second. And when we do this out, we get about 88 feet per second. Okay, so pretty straightforward when you write all your expressions like this, keeping track of your units in the numerator and the denominator. Because then once you know where you want to go, you know what kind of expressions you need to relate, what kind of conversions, excuse me, that you need to relate one unit to another. Okay, so let's go on to part B. It says the acceleration of a free-falling object is 32 feet per second squared. And it would like us to put this into meters per second squared, and it tells us that 1 foot is 30.48 centimeters. Okay, so we want to get this into meters per second squared. The second squared is good. That's great because that's what we want in our denominator, but we want this numerator to be in meters and not in feet. So it actually tells us how many centimeters are in a foot. Okay, so let's go ahead and convert to centimeters, because we don't know immediately how many meters are in a foot. Right, you might know, but this problem isn't giving it to us. So first we'll convert centimeters, feet to centimeters, and then we'll convert centimeters to meters. And just by knowing SI prefixes, you should be aware that centimeters, there are 100 centimeters in a meter. So we'll then convert this to meters, right, by doing the necessary conversion of meters to centimeters. Okay, so the problem gives us that there are 30.48 centimeters in a foot. And just know that every time I'm doing this, and I just put like a unit in the numerator or denominator, I just mean there's a 1 there, right? This is per 1 foot, right? Because really this is 32 feet per 1 second squared. Okay, and then so there's 1 meter per 100 centimeters, right? So then when we go through and examine what units we're left with, we see hopefully that we did things correctly, and that the centimeters cancel out and the feet cancel out, and we're left with meters per second squared. And this turns out to be approximately 9.8 meters per second squared. Okay, so going on to part C then, tells us that the density of water is 1 gram per centimeter cubed. Gram per centimeter cubed. Right. And it wants us to convert this density to units of kilograms per meter cubed. Alright, so first of all, we'll do the kilograms. We need to know how many grams are in a kilogram. And again, from knowledge, I can't draw a straight line all of a sudden. Close enough. From knowledge of our SI prefixes, we should know that there are 1,000 grams in a kilogram. Okay, so once we do that multiplication, we'll get rid of the grams, and we'll be in kilograms. Okay, so that's half what we had to do. But now we have grams per centimeter cubed, and we want it in grams per meter cubed. Okay, so we don't actually know how many. I mean, you might know, but let's pretend that you don't. Let's pretend that you don't know how many centimeters cubed are in a meter cubed, although you should know how many centimeters are in a meter. So there are, like I used in the previous problem, right? Using the previous problem, there are 100 centimeters in a meter, right? So now I'm just using that fraction, but upside down. 100 centimeters in a meter, but I need to get rid of centimeters cubed on the bottom, right? And I need to replace it with meters cubed on the bottom. So really, I'd need to do this 3 times. So another way of saying that is just cubing this expression. Okay, so one thing that trips students up is that now I need to actually apply this cube to the 100 as well as the units inside of here. So both the number and the units get cubed. So I'll cancel this out, and I'll put the cube on the inside. This is actually 100 cubed on the inside now. Okay, and then we can go through and cancel out the units. Now centimeters cubed cancels with this centimeters cubed, and we're left with kilograms per meters cubed, which is what we wanted. Okay, so then we can multiply through, and it turns out that this is 1,000 kilograms per meter cubed. Of course, if we're concerned about significant figures, then you should denote this as something like 1.0 times 10 to the third kilograms per meter cubed. But there's your answer. So key thing to think about in these problems is, write out carefully the units that you have, and then think about where you want to go with those units, and just apply transformations in order to get yourself there.